One of the most overlooked reasons why supplements can be harmful to some individuals but not others lies in our genetic differences, specifically how our bodies metabolize and detoxify substances. People often assume that supplements affect everyone in the same way, or that what's safe for one person must be safe for another. But this is a dangerous oversimplification. In reality, genetic variations in liver enzymes, transport proteins, and immune responses can dramatically change how a person processes a compound. For some, these genetic traits can turn a seemingly harmless supplement into a toxic threat, particularly when it comes to liver health. Green tea extract is a prime example. The key antioxidant in green tea, epigallocatechin gallate, EGCG, is generally considered beneficial when consumed in modest amounts, like in a brewed cup of tea. However, in supplement form, where doses are far higher and absorption is concentrated, EGCG becomes much harder for the liver to handle. Some people carry genetic variants that make them slow metabolizers of EGCG. These individuals may accumulate higher levels of the compound in the liver, where it can cause oxidative stress, inflammation, and eventually hepatocellular injury. Several documented cases of liver toxicity from green tea extract involve individuals who showed signs of genetic vulnerability, although they often had no idea they were at risk until symptoms appeared. The same principle applies to many other supplements, especially those metabolized through the cytochrome P450 enzyme family, a group of liver enzymes responsible for breaking down a vast array of drugs and bioactive compounds. Variants in genes such as CYP1A2, CYP3A4, and CYP2D6 can influence how fast or slow a person metabolizes certain ingredients. For example, people with reduced CYP3A4 activity may be unable to clear high doses of curcumin from turmeric or monocolin K from red yeast rice efficiently, leading to greater accumulation and toxicity risk. These same enzymes also metabolize many prescription medications, which means individuals with slower metabolism may also experience amplified drug supplement interactions, even at normal doses. Another gene of concern is UGT1A1, which helps in the glucuronidation process, one of the liver's key detox pathways. People with mutations in this gene may have difficulty clearing certain polyphenol and flavonoids found in supplements, leading to greater stress on the liver. Over time, this can result in liver enzyme elevation, cellular damage, or immune-mediated reactions. Similarly, variations in HLA genes, which govern immune tolerance, have been linked to drug-induced liver injury and may play a role in supplement-related hypersensitivity reactions as well. Importantly, most people are unaware of their genetic profile. Testing for drug metabolism or supplement tolerance is not standard practice, and very few supplement users undergo genetic screening before starting a new product. This means a person could be at elevated risk for liver damage or adverse reactions without ever knowing until symptoms like fatigue, nausea, abdominal pain, or jaundice begin to appear. And by that point, substantial harm may already be done. The danger is especially pronounced when people take high doses, use multiple supplements at once, or combine supplements with prescription medications. The cumulative burden on the liver and kidneys increases, and in genetically vulnerable individuals, the detoxification systems can be overwhelmed quickly. This helps explain why two people can take the same product at the same dose for the same length of time and have radically different outcomes. One may experience subtle benefits, while the other may end up in the emergency room with liver failure. Unfortunately, the supplement industry does not account for these genetic variables. Dosage guidelines are typically one-size-fits-all, with little to no differentiation based on age, body weight, medical history, or genetic predisposition. Supplement labels rarely, if ever, mention that people with certain genetic traits may be at higher risk. And because regulation is so lax, post-market surveillance of adverse effects is inconsistent, which means patterns of genetically linked toxicity often go undetected for years. This genetic variability also means that supplement research, even when conducted rigorously, may not apply universally. Clinical studies may report that a supplement is generally safe, but if the study population lacked individuals with specific metabolic gene variants, then the risks for those with different genetics remain untested and unknown. What works in a controlled trial doesn't always translate to real-world safety for everyone. To reduce the risk of genetic-related supplement injury, several precautions are warranted. First, anyone with a personal or family history of liver issues, drug sensitivity, or unexplained reactions to supplements should be especially cautious. Second, genetic testing through pharmacogenomic panels may offer valuable insights for individuals who regularly take medications or supplements. While not necessary for every user, such tests can identify slow metabolizers and highlight potential red flags. Third, it's wise to avoid high-dose or megapotency products unless absolutely necessary, especially those marketed with enhanced bioavailability ingredients like black pepper extract, piperine, which can increase systemic exposure to potentially toxic levels. Lastly, remember that your body's ability to tolerate supplements is not determined by marketing claims or influencer endorsements. It's shaped by your biology, and that includes genetic factors you cannot see or feel until it's too late. The safest approach is to treat supplements with the same care and critical thinking as pharmaceuticals. Just because a bottle says natural or clinically studied does not mean it's safe for everyone, especially not in high doses, or for prolonged use, or for those with a hidden genetic vulnerability.